For centuries, digging up the past meant relying on pure imagination. We found the bones of massive creatures, but interpreting them required much guesswork. The challenge is physical. Bones do not move, rocks do not breathe. You cannot put a 60-million-year-old ecosystem in a terrarium and observe it. Over the last few decades, researchers stopped treating fossils like museum pieces. They started treating them like complex engineering problems. By applying computational modeling, biomechanics, and thermodynamics, scientists can mathematically reboot Earth's extinct giants. The fossil record encodes the mechanical blueprints of the ancient world, waiting to be reverse engineered. In the ancient, murky depths of the Devonian Ocean, the absolute dominant force was Dunkleosteus, a heavily armored apex predator. Curious, this diagram maps the landmarks of its skull, revealing a 4-bar linkage mechanism. It is a system of interconnected joints connecting the craniothoracic region to the jaw. This linkage acts as a high-speed transmission. When the cranial joint elevates, it forces the jaw to snap open rapidly, creating a suction vacuum to pull prey in. A fraction of a second later, the jaws slam shut with a calculated bite force of over 6,000 newtons. 60 million years ago, Dinosaurs, the flightless terror bird, faced a completely different structural challenge on the plains of South America. Because modern birds have highly mobile skull joints, scientists needed to see inside the ancient bone to test its actual combat capabilities. They ran intact fossil skulls through medical CT scanners. This wireframe model reveals that the terror bird sacrificed typical avian joint mobility. Instead, it fused its skull into highly rigid, bony beams along the top and front. This geometry made the skull incredibly strong vertically. But if the bird wrestled a struggling prey side to side, the thin lateral bones risked catastrophic fracture. Those strict physical limitations dictated its hunting strategy. Dinosaurs fought like a boxer, relying on an agile attack and retreat strategy with precise vertical hatchet jabs to bring down its target. Biological mechanics dictate how an animal fights, but they also control the absolute physical limits of how large an organism can scale on land. Consider Arthropleura, a massive 2.5-meter-long millipede. For years, researchers assumed it reached this size because the ancient atmosphere was flooded with oxygen. This graph plots atmospheric oxygen percentages over millions of years. It shows the largest fossils of this giant arthropod appear in geological layers where oxygen was roughly 23%, nearly identical to the air we breathe today. Its scale was an engineering response to a specific window of time. Living in open coastal areas as a slow-moving detritivore with no natural competitors, it simply had the ecological space to keep growing. Every creature, no matter its size, depends on the stability of the environment. When the planet's total energy budget fluctuates, the thermodynamic engine of the Earth rewrites the physical rules for every living thing. During the Neoproterozoic Cryogenian period, the Earth entered a severe phase known as the Snowball state. This globe illustrates the runaway albedo effect. As ice sheets advance from the poles, their white surfaces reflect more sunlight away from the Earth. That cools the planet further, creating a feedback loop that continues until the ice reaches the equator. Geodynamic evidence suggests this deep freeze was triggered by explosive volcanism. Huge eruptions injected sulfur aerosols directly into the stratosphere, forming a layer that blocked incoming solar radiation. With frozen oceans and stalling carbon sinks, this thermodynamic crash created an evolutionary bottleneck, testing the absolute thermal limits of where life can exist. We no longer have to guess about Earth's prehistoric past. We now possess the tools to calculate it. The geometry of a terror bird's skull and the energy budget of a frozen planet are both governed by inescapable physical laws. The fossil and geological records provide the exact specifications of Earth's deadliest eras. Ancient life demonstrates that persistence is a matter of alignment, organisms succeeding by functioning within the strict boundaries of physics and engineering.